Hey, I am Trijant, and before we ever talk about linked list, we need to talk about memory. Not the definition, not the textbook diagram, but the real thing. What actually happens inside your computer the moment you run a C program? Where does your code go? Where do your variables live? Who cleans them up? These are not small questions. Every bug you will ever chase lives in the answer. So, let me show you something. I am holding your program's entire memory space right here in my hand. Right now, it looks tiny, but zoom in and everything changes. Let me zoom in. This is your program's virtual address space. Four regions, each one has a completely different job. We will go through them one by one, starting from bottom. The code segment. Every machine instruction your CPU will ever execute lives here. When you write int main in C, the compiler translates it to binary and loads it at these addresses. See those hex addresses? Each one is 1 byte, one instruction, read only. The CPU fetches from here, it never writes back. Your code cannot modify itself at runtime. The data segment. Global and static variables live here. Write int counters equals 0 at file scope and it sits at one of these addresses from the moment your program starts. Unlike local variables, nobody cleans this up automatically. It lives until your program exits. The heap. This is memory you request manually. Malloc in C, new in C++. You ask the OS for a block, it gives you an address. That block is yours until you explicitly free it. No automatic cleanup, no safety net. That is what makes it powerful and dangerous. Forget to free it, memory leak. Use it after freeing, crash. Lecture 4 is entirely about this. The stack. Every time you call a function, the OS pushes a stack frame right here. Local variables, function arguments, return addresses, all packed into that frame. Function returns, frame is gone instantly. No cleanup needed. That is why it is so fast. But it has a fixed size. Keep calling functions without returning. Frames pile up. Space runs out. That is the Stack Overflow error. Yes, that is where the website got its name. Four segments, one address space, all active the moment you run your program. Code at the bottom, data above it, keep growing up, stack at the top. In lecture 3, we go inside the stack, frame by frame, push by push.